Hello everyone. Today we're going to look at learning about conservation of momentum as part of your Year 10 Combined Science physics course. Today's learning objective is that students should be able to use the concept of momentum as a model to describe and explain examples of momentum in an event such as a collision, but we'll also be looking at explosions as well, so you need to understand what is meant by a collision and an explosion in physics. You also should be able to use the principle of conservation of momentum to solve mechanics problems in one dimension. We'll look at what that means. And I'm assuming that you already know these things. We've covered these in our previous lessons. Momentum, can anyone remember what the symbols in this equation stand for? Well, P is momentum, M is mass of an object, and V is the velocity of an object. So you should be able to, by now, calculate the momentum of one single object moving in one direction, and today we're going to look at how more than one object interacts with each other. You should be aware of the kinetic energy equation already, that we calculate that using a half mv squared. We're going to use that in some of our calculations today. And Newton's laws of motion, the three laws of motion. First, second and third law. First law being that an object remains stationary or continues in a straight line without being disturbed if no external forces act on it. Second law being F equals ma, where an object with a mass experiences an acceleration if an external force, a net external force, acts on it. And then Newton's third law of motion is that every action has an equal and opposite reaction of the same type of force. So the principle of conservation of linear momentum states that the total linear momentum of a system of interacting bodies is constant, providing no external forces act. This applies to collisions where objects move together and hit one another, and to explosions where objects fly apart from one another after initially being at rest. Here's an example of a collision and an explosion.